Electrolysis of molten compounds. Electrolysis of molten compounds. A binary ionic compound is one consisting of just two elements joined together by ionic bonding. When these compounds undergo electrolysis, they always produce their corresponding elements. To predict the products made at each electrode, first identify the ions. The positive ion will migrate towards the cathode and the negative ion will migrate towards the anode. Therefore, the cathode product will always be the metal, and the product formed at the anode will always be the non-metal. Example: electrolysis of molten lead-2-bromide. Method: add lead-2-bromide into a beaker and heat it so it will turn molten, allowing ions to be free to move and conduct an electric charge. Add 2 graphite rods as the electrodes and connect this to a power pack or battery. Turn on the power pack or battery and allow electrolysis to take place. Negative bromide ions move to the positive electrode anode and each loses 1 electron to form bromine molecules. There is bubbling at the anode as brown bromine gas is given off. Positive lead ions move to the negative electrode cathode and gain electrons to form a gray lead metal which deposits on the surface of the electrode. Diagram showing the electrolysis of lead-2-bromide. Worked example: identify the product formed at the anode and cathode during the electrolysis of molten potassium chloride. Answer: the ions present are potassium K+ and chloride Cl. The chloride ions are attracted to the anode and form chlorine gas. The potassium ions are attracted to the cathode and form potassium metal. Exam tip: remember, electrodes need to be inert such as graphite or platinum so that they don't participate in a side reaction with the electrolyte. 4.1.3 Electrolysis of aqueous sodium chloride and dilute sulfuric acid. Electrolysis of aqueous sodium chloride and dilute sulfuric acid. Aqueous sodium chloride. Brine is a concentrated solution of aqueous sodium chloride. It can be electrolyzed using inert electrodes made from platinum or carbon graphite. When electrolyzed, it produces bubbles of gas at both electrodes as chlorine and hydrogen are produced, leaving behind sodium hydroxide solution. These substances all have important industrial uses. Chlorine is used to make bleach. Hydrogen is used to make margarine. Sodium hydroxide is used to make soap and detergents. Product at the negative electrode. The H+ ions are discharged at the cathode as they are less reactive than sodium ions. The H+ ions gain electrons to form hydrogen gas. Product at the positive electrode. The Cl ions are discharged at the anode. They lose electrons and chlorine gas forms. The Na+ and OH ions remain behind and form the NaOH solution. Diagram showing the products of the electrolysis of aqueous sodium chloride. Dilute sulfuric acid. Dilute sulfuric acid can be electrolyzed using inert electrodes made from platinum or carbon graphite. Bubbles of gas are seen at both electrodes. Product at the negative electrode. H+ ions are attracted to the cathode, gain electrons and form hydrogen gas. Product at the positive electrode. O ions are attracted to the anode, lose electrons and form oxygen gas and water. Determining what gas is produced. If the gas produced at the anode relights a glowing splint dipped into a sample of the gas, then the gas is oxygen. Diagram showing the test for oxygen gas. If the gas produced at the anode bleaches damp litmus paper, then the gas is chlorine. Diagram showing the test for chlorine gas. If the gas produced at the cathode burns with a pop, when a sample is lit with a lighted splint, then the gas is hydrogen. 1.4 Electrolysis of aqueous solutions. Electrolysis of aqueous solutions. Extended. Aqueous solutions will always have water present, H2O. In the electrolysis of aqueous solutions, the water molecules dissociate producing H+ and OH ions. H2O rightwards harpoon over leftwards harpoon H++ O. These ions are also involved in the process and their chemistry must be considered. We now have an electrolyte that contains ions from the compound plus ions from the water. Which ions get discharged and at which electrode depends on the relative reactivity of the elements involved. Concentrated and dilute solutions of the same compound give different products. For anions, the more concentrated ion will tend to get discharged over a more dilute ion. Positive electrode anode. Negatively charged O ions and non-metal ions are attracted to the positive electrode. If halide ions Cl, bridge, I and OH are present, then the halide ion is discharged at the anode, loses electrons and forms a halogen chlorine, bromine or iodine. If no halide ions are present, then O is discharged at the anode, loses electrons and forms oxygen gas. In both cases the other negative ion remains in solution. The concentration of the solution also affects which ion is discharged. If a concentrated halide solution is being electrolyzed, the halogen forms at the anode. If a dilute halide solution is being electrolyzed, oxygen is formed. For example, for a concentrated solution of barium chloride, the Cl ions are discharged more readily than the O ions, so chlorine gas is produced at the anode. If the solution is dilute, however, only the O ion is discharged and so oxygen would be formed. Negative electrode cathode. Positively charged H+ and metal ions are attracted to the negative electrode, but only one will gain electrons. Either hydrogen gas or metal will be produced. If the metal is above hydrogen in the reactivity series, then hydrogen will be produced and bubbling will be seen at the cathode. This is because the ions of the more reactive metal will remain in the solution, causing the ions of the least reactive metal to be discharged. Therefore, at the cathode, hydrogen gas will be produced unless the positive ions from the ionic compound are less reactive than hydrogen, in which case the metal is produced. The reactivity series of metals including hydrogen and carbon. Electrolysis of aqueous copper sulfate. Aqueous copper sulfate contains the following ions: Cu2+, SO42, H+, and OH. Using graphite electrodes. Apparatus for the electrolysis of copper 2 sulfate using inert passive graphite electrodes. Product at the cathode. Cu2+ and H+ will both be attracted to the cathode, but the less reactive ion will be discharged. In this case, copper is less reactive than hydrogen. Copper ions are discharged at the cathode, gain electrons and are reduced to form copper metal. The half equation for the reaction at the electrode is Cu2+ plus 2E, right pointing arrow Cu. Product at the anode. SO42 and OH are both attracted to the anode. O ions lose electrons more readily than SO42. O lose electrons and are oxidized to form oxygen gas. The half equation for the reaction at the anode is 4OHO2 plus 2H2O plus 4E. Using copper electrodes. Apparatus for the electrolysis of copper 2 sulfate using active copper electrodes. Observations at the anode and cathode. The cathode increases in mass while the anode decreases. This occurs as copper atoms are oxidized at the anode and form ions, while copper ions are reduced at the cathode, forming copper atoms. The gain in mass by the negative electrode is the same as the loss in mass by the positive electrode. Therefore, the copper deposited on the negative electrode must be the same copper ions that are lost from the positive electrode. That implies that the concentration of the Cu2+ ions in the solute